Okay, so we're going to sketch the parabola that we just changed from this form, ax squared plus bx plus c, into this form, turning point form. So we've got both forms of the equation, which really makes it nice and easy to sketch. Remember in the first exercise I got you to sketch the parabola and you're only given this form. In other words, this has just been multiplied out for you already, or we turn this into turning point form, which in that first exercise you didn't work out the turning point because we didn't know how to do it yet. Right, so we're going to just run through this example so we can really take it nice and steadily. So we've got our axes here ready to go, x and y, and we need to sketch this parabola and we're going to show everything about it. X-intercepts, Y-intercepts, turning point, axis of symmetry. What should we start with? I'm going to go with the turning point because it's here. So here's our P value and here's our Q value. Did all that hard work to get the turning point. Easy. X minus 3, kind of doing the opposite, so it's moving right by 3, plus 4, so it's moved up. So it's gone right by 3 and up by 4. So it's sitting over here. That's our turning point. 3, 4. Okay. Happy or sad parabola? Happy parabola. This here is our A value. A is positive, so it must be happy. A is also sitting over here. A is positive, so it's a happy parabola. So if it's a happy parabola, I can already just draw this like here. Okay, which means, what are we definitely not going to try and find for this parabola? We're not going to try and find any x-intercepts because there definitely aren't any. We can see from our picture already. Happy parabola, we've got the turning point. Don't go through all the hassle of trying to factorize this or put it into the quadratic formula. It's not going to give us any solutions because there aren't any in the real number system. But we can work out the y-intercept. Y-intercept, we know its x value is 0. So we can just substitute that in to work out the y value. You can substitute into either equation. I want to substitute into this form because it's definitely going to be a bit easier. But you can choose. So f of x, but we're going to substitute 0 for x, equals 2, 0 squared minus 12, 0 plus 22. Whenever I saw an x replaced with 0, gives you 22. Let's write it in coordinate form just to remind ourselves what we're doing. Input was 0, output was 22. Input was 0, output was 22. That's our y-intercept. There's our parabola drawn. Okay. Said that we're going to put everything into our parabola. Let's put this axis of symmetry. So where does it look like you could put down a mirror and it would be the same on both sides? Well, you could put one down over here. Now what would that line be? It's a vertical line. So its x value is constant. And what is its x value? Well, it's the same as this turning point. So x equals 3. Okay, one last thing we could work out for our parabola. We could work out what the range is. Now the range is all possible y values. Remember in that very first recap video we looked at it and we said these are all the possible y values. Well, this graph, if you started from the bottom, doesn't really start until you get to this point here, y equals 4. So we know that it's 4 and it's everything above that and it includes 4. So we're going to say that y is greater or equal to 4 and y is a real number. But this is the important bit here. If you wanted to write this in another form, you could have said y is an element of 4 up to infinity. And definitely useful to know both forms of writing these inequalities. It includes 4, so we've got a square bracket. We can never get to infinity, so it excludes it. So there's our range. Our domain's all x values, so it's not too interesting. And there's everything we can write and sketch about our parabola. What about this previous one we ended up with? This one here with this fraction. Going to be a bit more fun, right? So let's do it. G of x equals 2. I'm just going to rewrite it down here. G of x equals 2. I think it was x minus a quarter squared. And then it was minus 25 over 8. Is that right? Minus 25 over 8. Minus 25 over 8. And we also had it in the form that it was given originally. G of x equals, let's go up, 2x squared minus x minus 3. 2x squared minus x minus 3. Okay, so second example, we need to sketch this. Have our axes always at the ready here that are going into my head. There we go. I'll be scrolling up shortly anyway. Okay, x, y. Not sure where to move out the way. Okay, so we're given this. We know that the turning point is pretty much given to us here. There's our p value. There's our q value. So it's a quarter and negative 25 over 8. That is the same as negative 3 and an eighth, just so we have an idea of where it is. So it's a positive quarter. Remember, it looks like it's a negative, but it hasn't actually moved left, it's moved right. So it's here and it's negative. Okay, this thing here, this a value, is telling us that it's a positive parabola. So I'm going to draw it. I don't yet know if it's going to go through a positive x or a negative x. So I don't want to draw it yet, but I've got an idea that the shape's like this. Now something's already whispering in my ear that it's going to look like this, and that it's going to go through negative y. Now look at this equation and see why that's the case. Okay, let's do that. Let's work out what the y-intercept is. So for the y-intercept, we know that the x value is 0. So it's going to be 0 something. So let's work out what g of 0 is. In other words, let's input 0 and see what the output is. So I'm going to do it into this equation because it's easier to work with than this form of the equation. Remember, they have the same equation, just written a bit differently. So we've got 2, 0 squared minus 0 minus 3 equals negative 3. So what we're working out again? Oh yeah, the y-intercept. So in 0, our output was negative 3. Got it written in coordinate form so we don't suddenly scramble for this negative 3 and just put it somewhere in our graph. We know that it's 0, negative 3. So therefore we know that it must go through there. So the graph must look like that. G, let's label it. This turning point is a quarter negative 25 over 8, or 3 and an eighth. This y-intercept, what was it again? Must have had a 0. Oh, where on our page do we have something written with an x value of 0? Oh, here it is. 0, negative 3. Okay. Now we can see that our x-intercepts are going to be a negative and a positive. So let's put in the bits of information we know. Y values are going to be 0. In other words, let's let y equal 0. 0 equals, let's keep using this form of the equation. 2x squared minus x minus 3. Remember in that first exercise you did in parabolas, you kept on multiplying this out. It's kind of been done for you. I'm definitely going to use the quadratic equation. Just because I'm late, I don't really remember how to factorize. We can just use the quadratic equation. So x equals minus b plus or minus the square root of b squared minus 4ac, everything over 2a, equals, fraction into my forehead, minus b, so 1, because it's negative negative 1. But if you want to, negative, let's do that, so it's clear. Negative negative 1 plus or minus the square root b squared minus 1 squared minus 4ac, everything over 2a. Okay, so we're going to punch that into our calculator, start with a negative and then positive, and we're going to get two values for x. X equals something, or x equals something out relating to our two x-intercepts. Let's see what we get. So we got minus minus 1. I'm just going to write 1 minus the square root of 1 squared, I'm just going to write 1, minus 4ac. Now I'm going to go 4 times 2 is 8, 8 times 3 is 24, and minus minus, so plus 24. Everything over 2 times 2 is 4. Or you can just punch the whole thing into your calculator. Okay, x equals minus 1. Or, instead of a minus at the top here, I'm going to put the plus in. So I'm just going to take it into my calculator, and I'm going to change the minus to a plus. Okay, equals 3 over 2. Now, for those of you that factorized or needed to factorize it now, you might have gone, well, that wasn't actually too bad to factorize, was it? 2x and x plus 1 minus must be 3. Let's check. 2x squared minus 3x plus 2x. So it wasn't too bad to factorize. Either way, I don't know if it's going to come out nicely or not. Really is going to be up to you. Most of the time, you're probably just going to reach for the quadratic equation and go for it unless the factorization comes to you straight away. The point is, we've got our 2x intercepts, minus 1, 0, and 3 over 2, 0. Put that back into our graph at least, minus 1 and 3 over 2. Okay, quite a bit of work. We did the hard work of changing into turning point form. That meant that we could find the turning point. Other bits are things you've done already, but we keep on reinforcing these same ideas. To find x-intercepts, y is 0. To find y-intercept, x is 0. Our shape, we know because a positive a gives us a happy parabola. And you see, it's kind of these same concepts. Okay, so now you should be well equipped to sketch some of these functions. So I've put some exercises on the website of what to do. I'll write them out here as well. Exercise, I think it was 6.4, and it was question 4, and I'll add them to the end here, but they're on the website. I just need to hit publish and they'll be there. So this is what we're doing today, being Monday, Tuesday into Wednesday as well. Tuesday, Wednesday for our classes. Let's pop into the Google Meet, discuss anything that's not quite clear, and let's keep at it.